Okay, in this video we're going to learn on how to interpret or to describe distance time graph, or we may call it as DT graph. Okay, so DT graph means that y-axis is distance, D, x-axis is time, T. So we're going to start with 0, 0 here. Okay, for distance, okay, let us label all this axis. Okay, for distance, normally the unit that we're going to use is in meter. For time is in second. SI units for distance is meter, and the SI units for time is second. But then we can also have distance. The unit for distance is in kilometer, time in hour. In this video, we're going to discuss about basically 5 normal shapes that we can find under distance time graph. Okay. Alright, let us start with horizontal straight line first. Okay, this one is start from 0, 0, and this one is away from the starting point. The distance is several meters from starting point. Okay, here we have straight horizontal line for distance time graph, and what can this horizontal straight line tell us about the movement of the object? Okay, basically from the slope or gradient of DT graph, we can obtain the speed of an object. So gradient or slope. So we can obtain the speed about the object. So if we look at this horizontal straight line, so we can say that the gradient is equal to 0. So if the gradient is equal to 0, so we can say that the speed also is equal to 0. So what does that mean? So basically, we can say that, okay, maybe we can put it like 1 meter from the starting point. So the object will stay at 1 meter from the starting point all the time. So means that the object is not moving. Not moving. Right. Okay, so that one is horizontal straight line. Okay, what about if we have, okay, let's say we start like 0.5 meter from the starting point, and the graph is sloping up like this. Okay, from the gradient we can tell that the line is having constant gradient. So gradient is constant. Okay, from this gradient we can say that the speed also is constant. Okay, what about the movement of the object? So if you can see here, okay, the object is start from 0.5 meter from the starting point, and it will move away from the starting point. So it will move away from starting point with constant speed. Okay, what if we start somewhere around maybe 1.5 meter, and the gradient is like this. Okay, instead of moving away, so we can say this one start from 1.5 meter, it moved toward 0 starting point. So gradient is constant, and speed also is constant, right? And it moved closer to starting point, or we can say 0, 0. Okay, alright. So if you look at here, the gradient, this one is constant, meaning it's positive. Okay, moving up. Okay, the gradient is positive. So this one is constant, but then the gradient is in negative value.